Hi, this is my Module 1 Mastery assignment by me, Eva Manglona. And today we're going to review partial fractions decomposition. With this method, you are finding the parts that make the single and complex fraction. Partial fractions are useful when solving for complicated fractions and can be useful in solving for integrals, which I will go over later in the video. Now I'm going to show you how you can use this method. Here I have this example 5x minus 4 over x squared minus x minus 2. Then you're going to factor out the bottom using the good old AC method. And then you are going to write one partial fraction for each of those factors. Then you are going to multiply through the bottom so we no longer have any denominators. So what you're going to do is cross multiply to get a common denominator. Once you do this, you're going to disregard the denominators and just focus on the numerators. Next, you're going to find the constants. You can do this by substituting the roots or the zeros in the bottom, or as you can see here. So I just substituted in -1 into 5x minus 4, and as you can see, if you put in -1 into x plus 1, it'll be 0. And then I came out with -9 equals -3, and you divide that, which therefore b equals 3. I did the same with the other side. That's supposed to be a B actually, where I wrote A. Sorry. And as you can see, we got our A and B, and we just plug it in to the partial fraction, and there is your final answer. Here's a shortcut that can make decomposing partial fractions much easier and less time consuming. As you can see, I'm using the same example in the previous problem, from the previous problem. You just write out one partial fraction for each of the factors we found. And then you find the zeros. Now you will cover up x minus 2, because if you plug in the 0 there, it will equal 0. So then all you have to do is plug in 2 into 5x minus 4 over x plus 1. And as you can see, we'll get the same answer as the previous method we did, and do the same thing, but this time for b, all you have to do is cover up x plus 1 because that will equal 0. Plug in 1, and there you have it, 3. So the final answer will be 5x minus 4 over x squared minus x minus 2 equals 2 over x minus 2 plus 3 over x plus 1. Now we will review integrating partial fractions. When you know a fraction has non-repeating linear fractions in the denominator, and you also know that the numerator has a smaller degree than the denominator, you can use partial fraction decomposition to solve the problem. Once your partial fraction is decomposed, you can use natural logs, which are a major key, to integrate partial fractions. Why, you might ask? Well, this is because we know that when you integrate 1 over x, it'll equal ln x plus c, of course. Here I will show you how to use this method. We are using the previous example when we were solving for the how to decompose partial fractions. And first step you will do is write the problem into 2 separate integrals to make it easier for you. And here I'm writing the integral of 2 over x minus 2 plus the integral of 3 over x plus 1 dx. Next, you're going to pull out the constants. So pull out the 2 from the integral of 1 over x minus 2 dx, and pull out the 3 from the integral of 1 over x plus 1 dx. And after that, now you're ready to integrate using the natural log. And your final answer will be 2 ln x, absolute value of x minus 2, plus 3 ln absolute value of x plus 1, plus c. And make sure you do not forget your plus c. Very important. I hope you learned a lot and enjoyed. Thanks for watching.